Today we're going to be using Newton's law of cooling. This is the formula that we're going to be using. And the question is, just before 6 p.m., students enter the classroom to find Mr. Fee's dead of an apparent homicide. At 6, the temperature of the body is 80 degrees, while at 7 p.m. it was 75 degrees. If the room is kept at a constant temperature of 70 degrees, what is the time of death? So, T is the temperature. TA is going to be the temperature of the room, which is 70 degrees. And then the temperature of the object, which is the body. And that is going to change throughout each equation. And then we need to solve for K and T. So we need to solve for K to find the rate of decay, so then we can find time and the actual time of death. So to solve for K, we're going to do 75, which is the temperature of the body, at 7 p.m. And I'm going to do 70, which is the temperature of the room right here, plus 80, the temperature of the body taken at 6, and then again 70, the temperature of the room. Then we're going to do 1. There's 1 hour between the first and second temperature taken, so we're going to subtract 70 right here, and we'll have 5, and then 80 minus 70 is 10, E minus K. So now we need to divide by 10 to get rid of that over there. And then we also need to get rid of E. So we're going to do 5 over 10 equals ln E minus K. And since we did ln over here, we need to do it over here. So now that's going to equal 1. So we have ln 5 over 10 equals negative K. So we need to divide by 1, both sides, to find K. So we're going to go to our calculator, and we're going to do ln 5 over 10, and then negative 1. And it's going to give us 0.693. And then we're going to store this, store alpha K. Okay, so K is the rate of decay. So we're going to use this to find T. So in doing that, we're going to, now we're going to use 80. So 80 is the temperature of the body at 6 when they first find him. And then we have 70, which is the temperature of the room. And then we're going to use 98.6 right here because this is the initial temperature of the body, minus 70, sorry, forgot to put a plus sign, E minus KT. And now we're solving for T. So we're going to subtract 70, and that's going to be 10 equals 98.6 minus 70 is 28.6. E minus KT. So again, we're going to divide 28.6 to get rid of that, and then ln to get rid of E. So ln 10 minus 20.6 equals ln E minus KT. So again, that's going to make 1. So we have ln T divided by 20.6 equals negative KT. So now we're going to divide by K. Okay, so we're going to put this into our calculator. We have ln and then 10 over 28.6. And since we stored K, all we have to do is negative alpha K. And that's going to give us 1.51. And we're going to round to the nearest tenth since we're using hours. So now that we know that the time is 1 hour and a half, and they initially found him at 6 p.m. So we're going to take away 1 hour and a half, which gives us a time of death of 4:30.